Okay, this is George and I'm doing homework 5, question 1. Here is my answer and let me tell you how to do it. Okay, here is a question that x and y are independent with the two density functions, and z is x added by y, and we need to find fz by the first convolution method. We use the convolution method in the first question, and then we use the geometric method to do the same question. Okay, for the first one, we know that for the z equals to x and y, we need to consider that for the fx here, it is not easy. We should simplify this question that we can shift the result to the right side. We can see that for the fz, it means that it equals to fx convolute the fy. So the z equals to x added by y. So we can see for the x, if we shift the result to the right side by 1, its graph looks like this. From 0 to 1 and here. This is fx when shifted by 1. And this is fy. And we need to convolute this two density function and then get the density function of the z. So we can see that we need to do this. Fz equals to fx convolute y. Okay, by the calculation, we can get the result that it is this. But this is not the final answer because we have shifted the function value to by 1 of the density function of x. So we need to go back to the original function of z. So we can see that for the function density function of z, we can get this. And this is the final result of the question. Okay, I need to erase all the answer for the question 2 because we need to draw the graph. Okay, for the question 2, we can separate this question to 3 situations. For the first one, if the z is less or equal to 1, we can find the graph that it is here. For the x and y, it makes up a square that z is the line z, which is z equals to x added by y. It is here. And the probability we can find is here. So we can find the probability function of z is, which is this. It needs to smaller or equals to z, and it means that it is here. It is area of the shadowed part. So we can use this to find the density function that we can here. It equals to z. And for the next situation, z is between 1 and 2. We can get the graph here. It is some part out of this square. And this is g equals to x added by y. So we can see this probability function of z equals to here. Okay, and we can find the density function equals to and for the z larger than 2, we can see it's out of the square totally. So the probability function of the z is 1, and the density function of the z is 0. So we can get the Fz easily by this. Okay, it is the same as question 1. So we can see that the graph method or the geometric method is much more easier than the convolution method.